Another approach, as opposed to estimation, is to conduct a hypothesis test. So keep in mind these two big tracks of inferential statistics is estimation and hypothesis testing. So with hypothesis testing, the idea is we're going to use a sample of data to test claims made about a population. Right? So we're now going to cover in detail the one sample z-test for a sample mean. There are 5 main steps for testing a hypothesis test. First of all, this sort of preliminaries, you should state the target population. So are you interested in generalizing to the population of the United States, or maybe all beers brewed in a particular week? State your target population. And then what you need to do is you should state your parameters of interest. So are you actually interested in the population mean? Because maybe you're actually interested in some other quantity of the population. So once you have those preliminaries out of the way, we have 5 tests once you know you're interested in the population mean. First is you state the null and alternative hypotheses in terms of H subscript 0 or H subscript A. Right? Sometimes you'll hear H subscript 0 called H naught. But the key point is that you need to express your hypotheses in this language. Then what you do is you select a significance level alpha. Alpha we typically set to 0.05 by convention in the social sciences, but you will see that in some contexts, in some research fields, people use a different level of alpha. And that just reflects a different perspective on how willing people are to make a type 1 error. In some fields, they don't want to make a type 1 error very frequently, so they set alpha to a lower level, alpha to 0.01 rather than 0.05. And then what you need to do is you need to compute the test statistic, which we call z. So that's the third step. And then what you do is you assume the null is true. So you say, well, I think, I'm just going to assume the null hypothesis is true. And then you make a decision by either comparing the test statistic z with the critical value or values, or you compare the p-value with some significance level based on alpha. And then what you do is you state your conclusion. I also highly recommend, as sort of an additional step, to calculate a 95% confidence interval, or z-interval, to better understand what's going on. So first of all, step 1, state the hypotheses. So the null hypothesis, it's almost always an equality. So we use mu naught, mu subscript 0, as some claimed value for the population mean. Right? So if you think the population mean is 50, let's say, the null is going to be mu equals 50. So mu naught is 50. The alternative has 3 different variations. You can either have what we call a two-sided z-test, where the alternative is simply that the population mean is not equal to mu naught, or mu subscript 0. It's just not equal to that claimed value. Or we might have a right-sided z-test, in which the alternative is that the population mean is greater than the claimed value. Or a left-sided z-test, where the alternative is that the population mean is less than some claimed value. Most commonly, you will see a two-sided z-test, and we'll focus a little bit more on two-sided z-tests, but in some contexts, a right-sided or left-sided z-test is also used. Then what you do is you choose a significance level alpha. Okay, again, typically researchers use alpha of 0.05, and this is the criterion for what we call statistical significance. Right? This is very important because our level of alpha, right, it determines, in some sense, our conclusions. Right? We use alpha to compare with our p-values. We also use alpha to calculate the critical values on which we base or evaluate our test statistics. And we also use alpha to compute confidence intervals. Right? Because a confidence interval is 1 minus alpha times 100. So if alpha is 0.05, it's 0.95 times 100 is a 95% confidence interval. So choosing alpha will affect our decision whether we reject the null or not. And again, that's because alpha is the probability of a type 1 error or false alarm. Right? So the question is, how willing are you to have a type 1 error? By convention, right? In the social sciences, we set alpha to 0.05 with the idea being that about 1 in 20 times you're going to commit a false alarm, a type 1 error. But the idea is by convention we're okay or comfortable with that. In other contexts or other fields, alpha is going to be at a lower level. All right, and with that, we're going to explore this idea of setting up hypotheses and working with setting a level of alpha, which will in turn affect our conclusions with a hypothesis test.